is 4. So you see on the first line right here, on the line 1, the smallest value is 0. And the maximum value is 4. Okay? And you do the same for the other 3 lines, and you find the max of all the max. You find the mean of all the mean. It's going to be the absolute max and absolute mean. So again, L2. L2 is what? This line is horizontal line, so y equal to 0. And x have restriction. X from where to where? X is from 0 to 3. And do the same strategy. Looking back to the equation, I got what? F of x, 0, because I know y 0. X is somewhere 0 and 3. X 0 is what? X is f, y 0, so this is x squared. And x from 0 to 3, so x squared is going to be somewhere from 0 to 9, right? 3 squared is 9. So among those 2 lines, I know that 9 is bigger than 4, so this is more like an absolute value, and 0 seems like minimum. And we have to take care of the other 2 lines, so this is called L3 right here, L4 right there. Okay. Okay. L3. L3 is what? X equal to 3 and y run from 0 to 2, right? This line right here, x equal to 3 and y is between 0 and 2. So I'm going to plug in x equal to 3. So f of 3y, x is 3, this is 9 minus x is 3, right? So 3, 6y plus 2y. So f of 3 comma y is going to be 9 minus 4y. Okay, so this is 9 minus something. So you subtract a bigger number, you have smaller value. Subtract smaller number, you got a bigger value. And y run from 0 to 2. So if you plug in y equal to 0 right here, 9 minus 0 is going to be 9, which is the biggest value, so less than equal to 9. And then plug in x equal to y equal to 2, and 4 times 2 is 8. 9 minus 8 is 1. This is going to be greater than equal to 1. See, you subtract a bigger number, you got a smaller value. Okay, so on the third line, the maximum value will be 9, and the minimum value is 1. So 1 will not be your absolute minimum, because I can find somewhere that's some values even smaller. Right? And similarly, the last line, L4. L4 is what? Y equal to 2, right? The horizontal line right here. And x run from 0 to 3. Excuse me. And then do the same thing. F of x comma 2, because I know that y is 2. Okay, x squared, y is 2, so minus 4x, and then plus 4, y is 2, right? Oh, I see, this is a perfect square. And if not, you just, you don't know this, you just function of one variable. You take the derivative, you set the derivative equal 0, come back to tau plus 1, okay? But this one is easy to take care of. This is what? X minus 2 squared, right? So the minimum value is 0 when x equals to 2, okay? It's always greater than or equal to 0. And the maximum value, you try the endpoint, because same thing is closed interval, so absolute mean, absolute max is going to be at the endpoint. When x equal to 0, you got what? 0 minus 2 is negative 2 squared is 4. When x equal to 3, 3 minus 2 is 1. 1 squared is just 1, so 4 is bigger. This is between 0 and 4, because for x equal to 0, I got this. Okay, so solving for the 4 lines, you see what out of the math, 9, 4, 4, 9, so the absolute max is at 9. Absolute max equal to 9, and absolute mean will be equal to 0. Right? This is greater than 1, greater than 0, greater than 0, greater than 0. So absolute max will be 9. Absolute mean will be 0. Okay, and you can see the question not just ask you to find the absolute max, absolute mean. They ask you to find the value of x and y that's got the max or mean usually. So 9, right? 9 is right here. When you have x equal to, the absolute max is 9, when x is 3, okay? When x is 3. And when x is 3, in here x is 3 and y is 0, so you have the point. that's 3 comma 0. Okay. What about right here? You got the absolute is y equals 0. Yeah, y equals 0, then x equal to 3. Again, y 0, x is 3. So it's the same point. Y is 0, x is 3 is going to be right here. This one going to give you an absolute max. And absolute mean when equal to 0 when 0 right here, when x equal to 2, right? In here, when you got absolute mean right here when x equal to 0, right? And mean right here when x equals 0. X equals 0, what about y? X equal to 0 and y is 0, yeah? So I think it's a point right here. Right? X equal to 0 and y equal to 0, yeah? So it's the mean, x equal to 0. Where is it? Into the mean right? Oh, right here. This is 1 already. So right here, x equal to 2. We have mean right here. It's x equals 0, y equals 0, right? 0, 0. How about x equal to 2? X equal to 2. You got mean is 0, y equal to 2. 2 comma 2. Right? You have another mean right here. When x equal to 2, still 0 and y is 2. So 2 points going to give you the local mean. Absolute mean 0, 0 and 2, 2. 0, 0 is right here. Okay. I think x is 2, y is 2, somewhere right here. Let me check for the answer in the book, see if we got it right. I'll just choose an example. Yeah. So local mean, absolute mean. This one is absolute max at this point, and this one is also absolute mean. So imagine if this is a surface up here, and on that surface, the point right there going to give you the lowest point. Point right here give you the lowest one. This point right here going to be the highest point. Okay. So even though in this section the word seems long, but actually it's pretty routine. You just really follow the step. First derivative set equal to 0. Find the critical point. Second derivatives, then find determinant, and depends on the sign of determinant, you may have local max, local mean, or center point, okay? And if you're looking for the absolute max, absolute mean, after all of those work I mentioned, you have to work on the boundary curve. This particular example is just 4 lines, so you're working 1 line at a time and find the minimum or maximum in each line, and together, the maximum of all the maximum is going to be the absolute maximum. The minimum of all the minimum on the line will be your absolute minimum, and that'll be it. All right, I claim it's pretty long most of the time, but it's very doable. And one thing that is very crucial for this type of problem is your algebra skill. Okay, so be very careful and keep practicing. Make sure that your calculation is correct. If you mess up with just one number or one line somewhere, then screw up the whole problem, especially when you deal with strange function, more special function rather than polynomials like a trig function, sine, cosine, or exponential function, or log functions. So you guys see them in the homework, all right? Practice. This help improve your skills. And this is the end of 14.7. Let me move on to 14.8. I'll be talking another type of finding maximum and minimum. But this time we're not talking about local max, local mean, or absolute max, and absolute mean anymore. We'll be talking about something called the constraint. So 14.8 is about Lagrange. Lagrange multiplier. Okay? So the idea of this problem is this. You are given a function. Could be 2, could be 3, 4, 5 variables. So let me just find an example. Okay? Fxy equal to something. Given a function. And then you're going to give you're going to be given a curve on the function. For instance, g, use f already. G is xy equal to a constant, and this one is function g equal to constant, constraint. Okay? So the question asks you what? Find the maximum or minimum of function f satisfying the function g. Okay? Find max or mean of f satisfying g. So for two variables function, I can try to kind of explain to you using geometry. It's like this. Say you have a mountain. Okay, this is my function f. Okay, it's a mountain. And then g is what? Just like the mountain road, the road that's go around the mountain. This is my function f. fxy. Okay, this is a surface. Okay, and g is this. It's a curve. It's like the road that help you going up on the mountain. Okay. This curve is function g equal to k. Okay. So it's a curve, right? Equal to a constant. Right. You have gxy only is going to be a surface with equal to constants. Just a curve. Okay. So the question asks you what? Find the maximum or the minimum point of the point on the mountain. That's that point gonna be on the road as well. Or you can say it this way: find the highest point and the lowest point on the road G on the mountain road on the mountain. Okay. So graphically, look, it seems like this is like the highest point, or maybe this point right here. I don't know. It's gonna be on the road on the G and on the F at the same time. Okay, that was the idea. And same thing for the lowest. Find the lowest point on the curve G and on the mountain F. That was the idea. And of course, if you have the 3 or 4 or 5 variables, the technique of solving this type of problem is the same, but I cannot draw it anymore because we can only draw 3Ds. Okay, that was the idea. And algebraically or graphically in this problem, how do you solve this one? The maximum point is what? The point that have the same tangent line. Okay. So if you draw the, I cannot draw it in here. You draw the level curve on F, and this is the curve on G. They have a maximum. You find a maximum point. That means what? At that point, the function F and function G gonna share the same tangent line. Share. This tangent line gonna be right here. Okay, inside out this way. Okay, same tangent line. And if they share the same tangent line, means what? They have the same normal line as well. And recall what we learned before, how to find a normal line. We do what? Gradient, right? So gradient is for F is denoted by this one, and gradient for G is denoted this one. This is the vector. Those are vector. Same direction means what? The two vectors are proportional. Means gradient F is going to be equal to lambda gradient G. Lambda is just a number. Okay, it's a number. And we call this lambda number the Lagrange multiplier. Lagrange multiplier. Okay, it's just a number. So if you can have a maximum that on G it's also on F, then what? The two normal vectors gonna be the same. As the same means so the same direction, right? May not be the same value if they're proportional by a constant. Lambda, and it's the same direction. So we have gradient F equal to lambda gradient G. Okay, and G is lambda here is some kind of constant, and since those are non-zero vector, lambda cannot be equal to 0. It's not 0. Okay, if this is 0, then we have a 0 vector, and it can point anywhere. Okay, and then together with the constraint right here, satisfy the values on x and y, you guys can find the maximum or the minimum. Okay, that was the idea. And the good thing about this section is the idea is pretty simple. It's the whole thing. This applies same way for x, y, z, essay 3, 4, 5 variables the same way. The harder thing is it doesn't have any general rules to apply to all kind of problems. It really strongly depends on relying on your algebraic skill to solve. But I can give you some examples, and I'll show you what I usually do to take care of the problem. And as I say, it really depends on the problem. Okay, different problem you may see different ways to tackle. But practice is the key. Okay, that's the idea. And let me extend the concept a little bit more before I forget. You may have more than one row on the mountain. You may have G right here. You may have another one called H, X, Y equal to K and then L. Okay? In other words, you may have another row. Say going this way. Okay? Now what? Find the point on the mountain that's on the row G, on the row F, that's maximum or minimum. So you have to look for the intersection, okay, of the two rows. And on the mountains, what is the highest intersection? What is the lowest point of intersection? So you have one more. G delta, not delta, this not blah, this what? Gradient F equal to lambda gradient G, and you have to solve another one. Plus lambda, how about mu of gradient, what? H, right? Yeah. So you may have more than one Lagrange multipliers. Could be 2, and then if you have another curve, it's going to be 3, 4. You can solve for it. Okay. So F is combination. You have 3 functions, going to be another one, fourth function going to be 1. But most of the time, I claim in our course, we're going to learn with just one constraint. The line for the constraint, okay? Just 1, 2, 3. You do the same way. Just add more. All right. So let's work on start with one example or maybe 2 examples, and hopefully you guys can learn some techniques of solving from it. Start with the first example, so let me choose something that's easy enough. Okay, find the extreme value of the function f x y equal to x squared plus 2y squared that satisfy the condition that x squared plus y squared equal to 1. So algebraically, if you don't want to do graphing anything, that's what I want to find the maximum value of x squared plus 2y squared, but under one condition, x squared plus just single y squared, x squared plus y squared equal to 1. So can I find the maximum of this values subject to this condition right here? Okay, that's what's the problem, but it's two variables. I can see you right, I'll tell you right away, this is going to be a problem. Look like this. Okay, look like this. Okay, and this is a circle. 0, 0. So you apply, think of it like a rubber band. You grab along the problem. You may have some like, let me use a different color. Something like this. See? The red curve is for that x squared plus y squared equal to 1. This actually is a cylinder, okay? And this is what x squared plus 2y squared is a parabola, okay? So you have to find the point on the parabola and also on the red curve, just that this is the highest point, and then same thing for the lowest point, okay? So think of this one right here is g. G is xy equal to x squared plus y squared, right? And k is 1, constant already. So you're going to calculate gradient f. Gradient f is what? Fx, Fy, right? So 2x and then 4y. Well, this is Fx. This is Fy. And then gradient g is 2x, 2y. This is gx, and this is gy. Okay? So we have a system of equation. We have gradient f equal to lambda, gradient g means 2x right here is equal to lambda 2x down here, and then I got 4y here for f equal to lambda 2y there, and that I have the constraint x squared plus y squared equal to 1. And my job is to solve a system of linear equation. Not linear. System of 3 equations with 3 variables, x, y, and lambda. Okay. Now, here comes the very, very common mistakes that I've seen over and over when people take care of the problem. See, the first equation, people try to divide both sides by x, or second equation, people divide both sides by y right away. And I claim that's not a good idea. Why? Because whenever you want to divide something or multiply something, you got to make sure that this value is non-zero. Okay, it's not zero. What if x goes to 0? Then you cannot divide, okay? So you have to take care of the special cases where x or y may be equal to 0 first, to make sure that this is taken care before you can divide. Okay, it was the first step that I would do. So I'll check for the case, looking at there, I'll check for the case when x or y may be equal to 0. And keep in mind that lambda is non-zero, okay? So first case, actually I can divide both sides by 2. First of all, make it easy. So what? X equal to lambda x, right? 2y equal to lambda y, right? And then of course x squared plus y squared equal to 1. So I simplify my system a little bit. So easier to work with. The first one, say if x equal to 0, what happened? First one is okay, right? And then the second one I don't know yet. But the third equation right here, x equal to 0, then I got y squared equal to 1, so y equal to plus or minus 1. Okay? So x equals 0, I have this. Now I'm going to use the second equation. If y equal to 1, then what? 2 equal to lambda, right? And y equal to -1, then -1 right here, so 2 equal to lambda. So we still have 2 solutions, and they worked. I may have, the point is what? 0, 1. This is 0, -1. Check it out. X 0, y is 1. And lambda is 2. Works for all the equation. Okay? Oh, see? Don't omit the cases. Don't forget the cases. Variable could be equal to 0. And similarly, check for the case y equal to 0. What happens when y equals 0? So the second equation right here gonna disappear, right? 0 on the left equal to 0 on the right. I have nothing to do. And I'm gonna look at the third equation, y equal to 0. I got x squared equal to 1. So x equal to plus or minus 1. Yeah, 1 squared is 1, -1 squared is also 1. So x is plus or minus 1. I plug in here. I have x equal to 1, so lambda equal to 1. And x equal to -1, I still have lambda equal to 1. So I have another pair of solution. X, y could be 1, 0, or -1, 0. Okay, x1, y 0, or x -1, y still 0. I have 2 more points. What if both x and y are non-zero? Then I'll write this way: x times y is not 0. It means what? Either none of those, neither x or nor y equal to 0. Okay, both of them not 0. Now, both x and y are not 0. I can legally, safely divide both sides by x in the first equation, divide y in the second equation. So I got what? 1 equal to lambda, and then the second equation I got what? Divide both sides by y. I got 2 equal to lambda, and then I got x squared plus y squared equal to 1, and this is no solution because lambda cannot be equal to 1 and 0 at the same time. No solution. So anyway, you guys are gonna have 4, okay? And now you want to see which one's local max, which one local min, and that's simple. You plug it back into the function. Oh, I erased it, so let me rewrite it. The function goes like f x y equal to x squared plus 2y squared, right? So plug it in. F 0, 1, x 0, y equal 1. This is 2. F 0, -1, x is 0, y is -1, still 2. F 1, 0, x is 1, y 0 is equal to 1. F -1, 0, still 1, right? So you see that the maximum is at 2, the minimum is at 1. It's the max. Those are the mean. Okay, so graphically, you have a paraboloid x squared plus 2y squared, and you have a rubber band that graph around this paraboloid. Rubber band looks like this. Hopefully it works. Okay, you see that you have two maximum. This is the max. This is not the max. 2 points got the same height. 2. Okay, and the point right here, the point right there, minimum. Okay. So you guys see that how we take care of a problem using Lagrange multipliers. Anyway, let me summarize the whole section for you. You have a function, okay? The question asks you to find the maximum or minimum value of the function, but now it's not about local max, local mean, or absolute max, absolute mean anymore. But the condition of this problem is to find maximum minimum of a function subject to another function. It's under some condition. And in this particular problem, find maximum minimum of this, satisfying x squared plus y squared equal to 1. Okay? And you use Lagrange multipliers. Find the gradient of f. This is g right here, gradient of g, and if you have a maximum minimum point, those two gradients are going to be in the same direction. Okay? So, and then you have a system of equations to solve, you have the answer. And one more time, there's no general formula to solve for the system of equations. So you really have to practice. And as usual, you got stuck. If the problem is too hard, please don't hesitate to ask, okay? I'll try my best to answer as quick as I can. Okay, so let me look for another example or maybe an exercise somewhere in the book. How about 3 variables? So it's going to be harder. Look for one. Exercise then. Okay, I'm not sure if it's easy or hard. Let's try it. F x y z is equal to x y squared z, and this is the function, right? Find the maximum minimum value of that function, satisfying the condition x squared plus y squared plus z squared equal to 4. So I'm unable to graph it anymore. It's too big for me, but I can solve my maximum minimum value using Lagrange multipliers. Okay. So normal step, gradient of f is respect to x. I got y squared z. For y, I got 2xyz, and for z, I got xy squared. Okay, and this is my function g right here. So I calculate gradient of g. I got 2x, 2y, and 2z. All right. So I have a system of equations. I have a gradient f equal to lambda gradient g, so y squared z gonna be equal to lambda 2x. 2xyz gonna be equal to lambda 2y, and then xy squared gonna be equal to lambda 2z. And together with the constraint function x squared plus y squared plus z squared equal to 4, I am having 4 equations with 4 variables, x, y, z, and lambda, and I have to solve all 4. Actually, you only need to solve for 3, x, y, and z, right? And you know the lambda is non-zero. Okay. Then, as usual, the first thing is you're going to make sure that and check if any of those variables x, y, z equal to 0. So let's check one at a time. What happened when x equal to 0? X equals 0, the first equation right here means what? Y squared z equal to 0, because x equals 0, right? So y squared z is equal to 0. Okay.